Okay, we've talked about what a solution is, and we've already even talked maybe about how you would get the solution, for example, to a linear system. But just to review, a solution, of course, is something that makes a statement true. And if it's true and it's an equation, well, what makes an equation true? I would say that it's true if the left side of the equation equals the right side of the equation. For example, the equation 2 plus 1 equals 3 is true because on this side 2 plus 1 is 3, and on this side 3 is 3. So the left side does equal the right side. So this is a true equation. So if we had, for example, the equation, which has an expression in it, the equation, not the linear system, just the equation 2x plus 4 equals 10. Most of us can look at that and say, I think there's a solution to that equation there, and I think the solution is that x equals 3. And then how would we check? Well, we want to know if our solution, that x equals 3, does make the left side equal the right side, if this makes this a true equation. And so we always check a solution by substituting that solution. And if we do a substitution, we have to declare that we have to communicate we're doing it. So we are going to substitute that x equals 3. And we're going to check in the left side and the right side separately. Okay, so when we substitute x equals 3 into the left side, we get 2 sub 3 plus 4, and if we simplify that all the way, it's 6 plus 4, which is 10. When we substitute in the right side, well, we have a 10 and nowhere to put the x, but we do notice right off the bat that, hey, the left side worked out to 10, the right side is 10, and so we are pretty safe to declare that the left side equals right side, and therefore x equals 3 is correct, or is the correct solution. Well, what if we had a solution to a function instead? What if we had, for example, the function y equals negative 1/3 x plus 6? Well, we remind ourselves that a function, of course, has an infinite number of solutions, right? It can be any combination of x and y that might make this true. And if just for myself, I want to say, okay, what does this actually look like? If I call that 6, this is a bit of a negative slope, so maybe it looks like this. Y equals negative 1/3 x plus 6. And I remind myself that every single point on this line, every coordinate, every combination of x and y that appears on this line is a solution. So here's a potential solution, 9, 3, x being 9 and y being 3. Is this a solution to y equals negative 1/3 x plus 6? Does this make this true? And when I say, is this a solution, I am saying at the same time, is this a point on the line? Is 9, 3 a point on the line y equals negative 1/3 x plus 6? Well, it's small now, but this still applies. I'm still going to check a solution by substituting that solution. And I'm going to communicate that substitution, and so I'm going to say I'm going to sub 9, 3 into, and I could write the whole line, but sometimes I just like to label my line with a 1. So I'm going to into equation 1, or into function 1. And here we go, remembering that I'm going to sub it separately into the left side and to the right side. In the left side, I've got a y, which means that I want to sub in the y value 3. And here we go. So the left side works out to 3, and I guess actually we're done. In the right side, we're going to substitute our x value, because there's an x value here to sub in. So we're going to go ahead and do that. So negative 1/3, substituting the fact that x equals 9, and then I have plus 6. Well, negative 1/3 times 9 is, I guess, negative 9 over 3, or some of you know how to cancel, but regardless, it works out to negative 3 plus 6, and negative 3 plus 6 is 3. and I have left side is 3, I have so the right side is 3, and so I write, therefore, left side equals right side, so 9, 3 is a solution. Or I could say is a point on the line, or I could say is a correct solution, but all those things are true. 9, 3 is a point on the line. And it is a solution to y equals negative 1/3 x plus 6. Now, just to run a quick second example, how about the point negative 3, negative 1? Is that a solution to y equals negative 1/3 x plus 6? So I declare my substitution. I take the left side and right side separately. I find the left side works out to negative 1 when I substitute in the y value. I substitute in the x value, negative 3, into the right side. And I find when I simplify it, I get that the right side, it works out to 7. And here I find, and therefore I find that the left side does not equal the right side, and therefore negative 3, negative 1 is not a solution. Okay, and now we get to checking the solution to a linear system, which is what we're really interested in here. You remember from a previous video that we think we solved this particular linear system by graphing, and we think that we found that the solution was 3, 5. So then, how do we check our solution? Well, as always, we check our solution by substituting the solution back in. Where do we sub it back in? Well, I guess we should maybe sub it into the first equation, I suppose, or the first function of our system. Declare, of course, sub 3, 5 into, and I'll just call it equation 1 because it's labeled as equation 1. And here we go in left side and right side. Well, when y equals 5, that makes the left side pretty simple. When the right side is 2, bracket sub in x equals 3, minus 1, that's 6 minus 1, that's 5. We get the left side equals right side in 1. Now, we have to just pause there for a minute and think, okay, what have we shown? What have we actually checked? What have we shown to be true? What we have shown to be true is that the point 3, 5 is on this line, is on 2x minus 1, which is great. We were hoping it would be because we need it to be that point of intersection. What we have not shown is that it is also true for our other line. Okay, so in order to do this correctly, in order to check the linear system solution, we have to check our solution by substitution into both function equations. So after substituting 3, 5 into equation 1, we are also going to, and again, communicate that we are going to substitute x equals 3 and y equals 5 into the second equation. Here we go. The left side, again, very simple. It's just y, so it's 5. The right side, we have negative 1/3, and we're going to sub in 3 plus 6. Negative 1 times 3. Sorry, negative 1/3 times 3 is negative 1 plus 6, and that equals 5. And so here we get that left side equals right side in the second equation, and we can make a conclusion about the fact that, hey, left side equals right side in both, and therefore 3, 5 is the correct solution. Right? It makes both of them true, and therefore it must be the solution to the system.